Hey everybody. Today we're going to keep learning even though I'm gone just because we don't want to fall behind the other ninth grade classes. Yesterday we did a lab on conservation of energy. We talked about the law of conservation of energy. Before that, how all energy in a system remains constant, it just changes forms. Today we're going to talk about how it makes those transformations from one form to another. The essential questions right here, I'm sure you want to read those quickly, but getting right onto it. So these are the types of energy. We've already talked about these types: electrical, chemical, thermal, nuclear, electromagnetic, mechanical. In a system, energy just flows from one of these types to another. We've already seen this slide earlier on when we first introduced energy. The types of energy: mechanical, that's like our gravitational potential, our elastic potential, our kinetic energy, that's the motion and position of everyday objects. Thermal is total heat. Chemical is energy stored in the chemical bonds. Anything that burns or explodes, or even anything you eat and your body converts the chemical energy into usable energy. Electrical, anything you plug in. Electromagnetic, this is all light from the sun. So any visible light, infrared waves, radio waves, X-rays, gamma rays. We'll spend a whole unit talking about electromagnetic waves in the future. And then there's nuclear. Nuclear is, we talked about that earlier in the year in our chemistry unit with the fission and the fusion, creating energy from the bonds within the nucleus of an atom. So how do energy transformations work? Energy can be transformed in other ways besides kinetic and gravitational potential. Those are the main two we focus on. Those are the main two you're going to see on the test, kinetic and potential. But there are other transformations. So electrical energy can be transformed into electromagnetic, light and thermal energy, heat. If you take a light bulb, plug it in, it gives off light and heat. It's turning electrical energy into light energy and heat energy. Think about an engine, how an engine works. An engine is a great example of kinetic energy, potential energy, chemical energy, heat energy. All these things are happening at once. Think about how you start a lawnmower. To start a lawnmower, you take your energy and pull on a rope, like a push lawnmower. You pull start it. That turns into kinetic energy of something moving. What's moving? Well, the flywheel is moving. It goes past the magneto, which creates electricity, which sends electricity to the spark plug, which starts a chemical fire for the gas explodes. That's releasing chemical energy. That chemical energy pushes on the piston. The piston in turn turns down and turns the lawnmower blade, but it also turns that flywheel again, which creates another source of electrical energy, which fires the spark plug again, which explodes again. And it's just a never-ending cycle. I guess it's not never-ending. If it was never-ending, that'd be perpetual motion. It does end when it runs out of gas. So that's the energy you have to keep adding to the system. You have to keep putting chemical energy into the system in order to keep it going. Another form of energy transformation from the sun. So the sun is electromagnetic energy that gets converted into usable chemical potential energy for the plant. That gets stored in the plant as chemical potential energy until something comes along and eats it. And then that gets turned into usable kinetic energy for that animal. Other forms of energy transformations: wind energy. So wind, what is wind? Wind is little chunks of air molecules up above the ground. So it actually has potential and kinetic energy. But if it's wind, that's moving air. So we'd say it has kinetic energy. That kinetic energy hits a turbine. The turbine spins, producing kinetic energy. That kinetic energy turns a generator, which converts the kinetic energy into electrical energy. That then goes off to your homes and you convert it into whatever you need that electrical energy for. That's basically how all power gets made. Most power gets made this way. It's some type of turbine. A turbine we'll talk about more when we get into electricity and magnetism, but it's basically a bunch of spinning electric coils and magnets that creates electricity. So all of your power plants, whether they are wind, water, nuclear, coal, whatever it is, they are turning a turbine. A windmill turns a turbine. A water in a dam, as water flows through it, it turns a turbine. Your nuclear, your coal, those are creating heat, which heats up water, which turns into steam, which the steam goes through a tube and turns a turbine, just like the wind or the water. that creates electricity. The electricity then gets put into our system. So just a whole bunch of conversions between nuclear power causing a reaction, causing heat, turning into heat energy, turning a turbine, which is kinetic, which the turbine creates electrical energy. So a whole bunch of just energy transformations. The total amount of energy isn't changing. It's just changing forms. Now, for just humans in general, when we are eating and moving every day, it's just a continually energy transformation process. If we took our body as the system, the total energy in that system isn't really changing unless we add energy to it. So we are continually adding energy to our body by eating things. So when we eat things, we could rank all of our food labels in terms of joules. 1 calorie equals 4,000 joules. So when you look at your bottle of pop you're drinking or the candy bar you eat, on the label it says how many calories are. That's basically how much energy you are intaking. If you intake more energy than you burn, you're going to gain weight. If you burn more energy than you intake, you are going to lose weight. That's the basics of how we grow. So every gram of fat a person consumes can supply about 10 calories of energy. Carbohydrates, proteins each supply about 5 calories of energy. Now, we have to eat daily in order to keep our bodies going. Even something as simple as sleeping burns calories. So just while you sleep, you burn some calories. Just sitting, your body doing all its normal functions burns calories. The process of eating burns calories. So as you're taking in calories, you're also burning calories. Most people eat more than 112 calories at a meal, so you're still gaining calories. Now, if you want to really burn calories, you start doing more aggressive things: walking, playing tennis, bicycling, running. A large person like myself, running for an hour, I will burn about 1,000 calories. That's also why larger people have a higher calorie intake per day. I think on average, it's about 2,000 calories people should be eating per day. Larger person like myself, maybe I think it's 2,500 calories you should be taking in per day, depending on how active you are. So again, your body every day is going through energy transformations. Other examples of energy transformations: television turning into light, a toaster turning electrical into thermal, a car changing fuel into thermal and mechanical energy because it heats up and the car moves, a flashlight changing chemical energy from the battery into light. When you speak, okay, you are creating kinetic energy with the air you're pushing out of your mouth. That's sound energy. That gets changed into electrical energy in the phone. The electrical energy travels down the line and gets converted back into sound energy or kinetic energy for someone else to hear you. Same thing would be true if you were talking through a walkie-talkie or a cell phone, except for now it's not electrical energy, it's electromagnetic energy. It sends radio waves when you're talking on a walkie-talkie or a cell phone. This example, light converted into electrical energy. So solar panels convert light directly into electrical energy. That's one of the ones that doesn't use a turbine like all of the other sources of energy. Campfires convert chemical energy stored in wood. Anything that burns has stored chemical energy, which transfers into something else. And then nuclear energy, we already talked a little bit about that with the nuclear power plant. So on a cold day, you rub your hands together to make them warm. Describe the energy transformations that occur, starting with the chemical potential energy that your muscles store. So I wake up in the morning, I eat some Wheaties. That chemical energy gets turned into usable stored energy in my body. Once I decide to use it, I start moving my hands. That's kinetic energy, rubbing my hands together. That creates friction, which creates heat. So the kinetic energy is being turned into heat energy that then dissipates into the environment around me. So that's it for energy transformations. Next on Monday, we'll talk about power. The power is a really short unit, so we're pretty much done. There are 2 labs, or at least one more lab I'd like to get done. But today, for the remaining period of time, there's assignments on Schoology. On Schoology, I'm going to run out of time here, so I got to go fast. The Quizlet is open to review, but first I want you to do the last 3 things on here. Start with conservation of energy, then energy transformations, then chapter review. Okay, start with these 2 for sure. Get those done today. Then keep moving on if you have time. Have a good day. Thanks. Bye.